I'm Dr. Rosemary, Associate Professor CEC in the Department of CEC in Rohini College of Engineering and Technology. So I'm going to take the subject CEC 088 wireless Adhoc and routing wireless Adhoc and sensor networks. To understand the concept of routing protocols and Adhoc networks, so routing and manage many factors affecting routing and manage models of topology, selection of routers, initiation of route request, specific underlying characteristics, application-based characteristics. Major goal in selecting routing protocols provide the maximum reliability, alternate routes if an intermediate node fails. So choose a route with at least a minimal or number of hops from source to destination. Give the nodes the best possible response time and throughput. Need for routing. Then route computation must be distributed. Routing computation should not involve the maintenance of global state. Each node must be concerned with the routes to the destination. Change routes must be avoided or directed. Eliminated broadcasts should be avoided. Broadcast can be highly unreliable. If topology stabilizes, the routes must converge to the optimal routes. It's desirable to have the back route. A major challenge in designing routing protocol must know at least how to route a packet via its neighbor. Network topology can change frequently. Large number of nodes could have a lot of information to update. So routing classification, proactive protocols and routing protocols. Proactive routing, reactive routing. And then keep routes. The proactive is when a packet needs to be forwarded, the route already know. So when there is a demand, when there is have a packet and you can have the data transmission, that's reactive. Proactive route available immediately. Reactive, a significant delay, a significant traffic control messages. So whether proactive is better or reactive is better, proactive is used to too much of bandwidth for control, updating routing information to keep its current all the time. Topology, it's never used. It's pure reactive is slow. So for real-time application, proactive is better. So routing type routing protocols, table driven, source initiated, and hybrid protocols. One by one. So source initiated on-demand routing. Source initiated on-demand routing. The second category of routing protocols. It includes AODV, DSR, and TORA, associatively based routing, signal stability routing. Adhoc is an improvement of DSDV. It's a node that the nodes that not in the select path do not maintain the information or participate in the routing table. So it will send the route request message to all its neighbors. It will find out so whether the neighbor is how much hop away. So propagate the route request. Then the path taken by the route replaces messages. Dynamic source routing contains two major phases: route discovery, route maintenance. When a mobile node has a packet to send it to some destination, it first consults its route cache to check whether it has a route to that destination, whether it's existing. If it's an unexpired node, so it will use that node. If node does not have the route, it initiate the route discovery by broadcasting a route request packet. This route request contains the address of the destination along the source address. Each node receiving the packet check whether it has a route to the destination. If not, it will add its own address to the record and along the path and forwards. Its route reply is generated when the route request reaches either the destination itself or an intermediate node that contains a route cache. If the node generating the route reply to the destination, it places the route record contained in the route request into the route reply. So creation of route record, then route during route discovery, propagation of a route reply with record. So temporally order routing algorithm, it's a highly adaptive loop-free distributed algorithm based on the concept of link reversal. TORA decouples the generation of potentially far-reaching messages from the rate of topological messages. Will be using the height metric. So height metric will be having h is equal to 0. The low level will be assigned will be h is equal to 0. Since it's a source will be it's the height of the tree 3. The protocol performs three basic functions: route creation, route maintenance, route erasure. During the route creation and maintenance phases, node uses a height metric to establish a directed acyclic graph rooted at the destination. Thereafter, links are assigned a direction based on relative heights. Propagation of the query message is given. The node's height updated as a result of update message. Associative based routing. Three phases of ABR: route discovery, route reconstruction, route deletion. In ABR, a route is selected based on the degree of stability associated with the mobile node. So association stability, how to assign the association stability? It's defined by the connection stability of one node with respect to the other over time and space. Each node generates a beacon to signify its existence. So when received by the neighboring nodes, the beacon causes their associative tables to be updated. The route discovery is accomplished by a broadcast query message BQ reply cycle. So when a discovered route is no longer desired, then the route node initiates a route delete broadcast so that all the nodes along the route update their routing table. Signal stability based routing. SSR selects a route based on signal strength between nodes and a node's location stability. This node selection criteria has the effect of choosing nodes that have better link capability. Hybrid routing protocols. Many of the hybrid routing protocols will be having 7 ZRPF zone routing protocol. The construction of a routing zone requires a node first know who is the neighbor. It's implemented through a MAC layer neighbor discovery protocol. Fish-eye routing protocol. They are multi-level fish-eye scopes to reduce routing update overhead in large networks. It helps to make a routing protocol scalable by gathering data on the topology, which may be needed soon. Landmark routing. It uses a landmark to keep track of a logical subnet. The landmark routing table includes only those nodes within the scope and the landmark node. Location aided routing exploits location information to limit the scope of routing. LR reveals the search based on the expected location of the destination node and thereby restricts the controls and the flood of route request packets. Distance routing effect algorithm for mobility. Based on the distance effect and a node's mobility rate, each node can optimize the frequency at which the update takes place and correspondingly reduce the bandwidth and energy level. So based on the calculated relative distance between two terminals, the query flood is localized to a limited region centered on the source node. Power-aware routing. Power-aware metrics are used for determining routes. It reduces cost to ensure that the mean time to node failure is increased without any further delay in the packet delivery. So the summary of the classification is given. So DSDB computed a priori, WDB route acquisition computed a priori, DSR on demand only when it's needed. So then DSR will have the delay in route recovery. So multipath capability not exploited. It's salvaging may quickly restore a route. DSDB updates the routing tables of all nodes ultimately, and updates the routing table of all nodes by exchanging MRL between neighbors. DSR route error propagated up to the source to the invalid. ZRP is a hybrid of updating routing nodes tables within a zone and propagating the